Find all solutions to the equation 3 tan x equals 2 cos x in the interval where x is between 0 and 2 pi. It could be 0, but it has to be less than 2 pi. Right, so this particular question, I'm going to do it analytically, as in using a non-calculator approach, and we're going to just do it using a calculator method. If you've got something like this in a paper too, and you just want to find the answer, it might be part of a bigger question, then it may be perfectly fine just to use a calculator approach, which is often a lot quicker. It's not always a lot quicker, but it certainly sometimes is. So we'll start with the non-calculator method. 3 tan x equals 2 cos x. We're going to use the standard substitution for tan x, that the second most common, most important trig identity is tan x equals sine x over cos x. So 3 sine x over cos x equals 2 cos x. Now, looking at that, the best way to deal with this is to multiply it through by cos x. So you don't want to be dividing by things, but to multiply through by something is absolutely fine. So we're going to multiply by cos x. So that is going to say 3 sine x equals 2 cos squared x. Right, so now looking at this, this is likely to lead us to a quadratic equation, and we want it just in one variable. So the substitution we're going to use next, we're going to use sine squared x plus cos squared x equals 1. So cos squared x can be rewritten as 1 minus sine squared x. So now we're using the most important, most common trig identity, the Pythagorean identity. So 3 sine x equals 2 1 minus sine squared x. Okay, just expand the bracket, and we're going to look to rearrange this so it equals 0, and hopefully we can factorize and use the null factor law. Failing that, it might be necessary to use the quadratic formula. We will see. So 3 sine x equals 2 minus 2 sine squared x. We want the squared term to be positive, so we're going to move everything over to that left-hand side. So 2 sine squared x plus 3 sine x minus 2 equals 0. So when you get something like this, you might just be really comfortable factorizing and using these terms. I personally find it a lot easier to do and to see and to explain if I use a u substitution. So I would say let u equals sine x, and we'll just put it back afterwards. So now we have 2u squared plus 3u minus 2 equals 0, and it just looks so much more familiar, so you should be able to factorize it a lot simpler. Okay, so hopefully it's going to nice prime number 2, so we're hoping we can get a 2u and a u. We're looking for factors of 2 as well, and if we times the 2, they're going to have different signs. If we times the 2 by 2, that'll get us a 4. And if we times the u by a 1, that'll get us a 1, and we should be able to combine the 4 and the 1 to get a 3. So the bigger term needs to be positive, this needs to be negative. So now we have 2u minus 1, u plus 2 equals 0. So that means 2 sine x minus 1 sine x plus 2 equals 0, right? So now, using the null factor law, one of these equals 0. So either 2 sine x minus 1 equals 0, or sine x plus 2 equals 0. Okay, so the first one would mean that sine x equals a half. That That's fine, we can deal with that. The second one would mean that sine x equals minus 2. So there's no x such that sine x equals minus 2 because the maximum value of sine x is 1 and the minimum value is minus 1. So there's no solutions from this. Okay, so for sine x equals a half, well, you should know by now using the handle or otherwise that sine 30 equals a half. Draw a circle. 30 degrees is there. Remember, pi is 180, so pi by 6 must be 30. Okay, and the other place this happens is if you use the symmetry of the circle. So that is going to be 30 less than 180. 180, yeah. This angle is going to be 150. Well, if pi by 6 is 30, 5 pi by 6 must be 150. So that must be 5 pi by 6. So the solutions are x equals pi by 6 and 5 pi by 6. So that's an exact approach. It's perfectly doable, but it did take a while. But I just want to show you, well, firstly, an exact approach might not be possible. And secondly, it just might not be necessary. So if you just need the numbers to use as something else, and they don't have to be exact, then it might save you that precious bit of time which enables you to pick up some marks elsewhere. So if we just go to the calculator to solve the initial equation, which is 3 tan x equals 2 cos x. So we just go to our calculator, make sure we're in radian mode, obviously. We are in radian mode. Go to the graph. And some people will tell you to make it equal 0, so plot 3 tan x minus 2 cos x. Personally, I would just plot them both and find the intersection, but it is entirely up to you. So 3 tan x. That's the first line. Second line, 2 cos x. We're going to draw them. We're going to need to, well, actually, the window's not too bad there, but we could potentially, we could make the x window between 0 and 2 pi. So I should be able to put 2 pi in here. Yep, that's good. And for the y's, well, we could say we know the maximum value of cos x is 1 and the minimum value of cos x is minus 1. So if we have 2 cos x, that's going to be 2 and minus 2. So actually, minus 3 and 3 here, that's not bad. So I think I'll just keep that. So if we draw that, you can see the two intersections. For working purposes, you might draw a sketch. I'm not going to here, but you could just draw a little sketch just to show that that's what you did. So shift, G solve, intersection, and we've got the first one at x equals 0.524. Very important point. If you are using a calculator method, if you're on a paper 2, you do need to give things to 3 significant figures unless instructed to do otherwise. It's really, really important that you need to train that 3 significant figures. So using GDC, like I said, you could draw a sketch, but I'm not going to. I've covered that in previous bits. So x equals 0.524. So that's the first intersection. Go across to the second one using the arrow. That is 2.617, so 2.62. We could use those as a check. E.g., you could, well, is pi divided by 6 0.524? Is 5 pi divided by 6 2.62? You could check that. So pi divided by 6, that looks good. And if we just times that by 5, that also looks pretty good. So you could just use it as a check, but remember these things, when you're in there doing a maths exam, time is incredibly precious.